This video proves everything I've been saying is true. Why it is we can't leave the Earth's magnetosphere. Now, it's going to be on a grand scale because they have to ease you into this. You didn't go to the moon. It was 230,000 miles away, Apollo went. Yeah, sure. No, it went 230 miles away. Take away 3 zeros. It's not as grand. They're not as good as they say they are. That's why we're 230 miles up. Not 230,000 miles up. Because that's as far as we went. They embellish the numbers. Simple as that. NASA does lie. The government lies. Yes, the government would lie to you. The government lies to you. Trump and Mike Pence are telling you you're going back to the moon, like Richard Nixon did, because only corrupt administrations do this shit. Bill Clinton said, why don't we try to get help from Russia to get 230 miles back up? Our shuttle's a little iffy. You know, not a long-term situation. How about habitants? There we go. Barack Obama closed down our bullshit, you know, George Bush moon landing. You know, it's not going to happen. These Mars missions, it's all fucking propaganda. To make you ignore simple things like the political game, the fact that everything we do at 230 miles up and around these fields of low Earth orbit have to do with everything political. Science is based in these fields. You want to know what's happening in the medical industry? You want to know what's going to happen with wars having to do with scientific technologies? Watch the space industry. You'll find out what Lockheed Martin and, you know, Sierra 47 and Boeing and all these places, they're all doing, and you'll know what's coming up next. Why you know that, you know, drones will be available and even better next year because this, or you know, finally there's going to be helicopter drones on Mars, in the Atacama Desert, all of these places. Meanwhile, we're still trying to figure out how it is to control things from the International Space Station at the Atacama Desert. So we're not actually doing such grand things, but they need to ease you into this. So this video is explaining everything I've been saying, but instead, they're going to say, instead of the Earth's magnetosphere, we can't leave, they're going to say the Sun's magnetosphere, we can't leave. And then they're going to talk about the fields of plasma radiation we can't even fathom. They're going to talk about everything that I have been saying perfectly.
While it's true that the Voyager probes haven't left the solar system as of yet, that doesn't mean they haven't gone far. They are in a place now that is defined as interstellar space, though that classification can mean many different things. In the context of this video, though, they're past the heliosphere. That is where solar winds emitted from our sun still blow things outwards. So in many ways, the probes are away from the reach of the sun. But what Voyager 2, backed up by data from Voyager 1, has found is that once they're outside that reach, the plasma that is out in space doesn't go down. It actually goes up in density by a large margin. The marked increase in plasma density is evidence of Voyager 2 journeying from the hot, lower density plasma characteristic of the solar wind to the cool, higher density plasma of interstellar space. It's also similar to the plasma density jump experienced by Voyager 1 when it crossed into interstellar space. And this is what is leading to the whole wall of fire thing, because this wall of fire is just outside the solar system, according to the probes. And that is a problem in many, many ways. The wall of fire outside the solar system is caused by electromagnetic EM radiation, which is created by plasma and a local space environment full of raging magnetic fields. But while this is terrifying, it proves that NASA was right to launch not one but 2 probes to go and explore the universe. Because for all we knew, the wall of fire might have just been in one centralized location, than a place basically filling up the boundaries of the outer solar system. The Voyager probes are showing us how our sun interacts with the stuff that fills most of the space between stars in the Milky Way galaxy, said Ed Stone, project scientist for Voyager and a professor of physics at Caltech. Without this new data from Voyager 2, we wouldn't know if what we were seeing with Voyager 1 was characteristic of the entire heliosphere or specific just to the location and time when it crossed. Number 5. The problem with plasma. Plasma, if you didn't know, is the 4th state of matter, and it was always known, or at least believed, that there was some outside of the heliosphere, as between the sun's emissions and the rest of the universe pouring things into deep space, it was basically pretty natural for it to be there. And when Voyager 1 first reached the point of interstellar space, it noticed some slightly larger levels of plasma, but it was Voyager 2 that showed that it was much bigger than anticipated. Plasma is very hot, and while the wall of fire is said to be somewhat colder than the sun's plasma it's dispersing regularly, it's still hot enough to mess with people and objects, which we'll be talking about later. But more importantly than that is that it's thick. This is well and truly a wall of fiery plasma, which means that if we want to get through this, we have to be careful in a whole host of ways. But more than that, it means that if there is this one wall of fire plasma in the universe, there could be many more, and that opens up a whole new can of worms for what we might have to do to explore the universe, and to survive it in the most basic of senses. Plus, we didn't expect this to be in such concentrations in this part of space, which means we were wrong in pretty much all of our assumptions up to this point about what lies just outside of our solar system. What else are we wrong about? What else have we not been able to understand about what's going on out there? Could we be missing something else? Lots of questions, ladies and gentlemen. Before we dive into more aspects of how this wall of fire will affect us, be sure to like the video and subscribe to the channel. That way you don't miss out on all of our weekly videos. Number 4. Leaks. As noted, there are many problems with this wall of fire, and one of them may just be how exactly this thing is forming. After all, scientists were a bit stunned by the density that the wall of fire exudes in interstellar space. But what might be even more surprising, though, is that Voyager 2 indicates that part of the reason the field of fire is so thick is that the heliosphere has a leak in it. This was discovered when the probe noticed that there were particles actually leaking out of the boundary of the heliosphere, which couldn't happen because of gravity and solar winds. But if it is happening in this area, it's possible that it's leaking the particles in other areas as well. The Voyager probes are on different sides of the heliosphere. One is near the front and the other is near the side, quite intentionally, I might add. So if the sun is unintentionally adding to this wall of fire, then that means that this field can grow every single day, and every single year, and beyond. So who knows just how big this field could get? Potentially, it could get so big that it starts to affect the heliosphere itself. We honestly don't know at this point. Thus, while many scientists are thrilled at what is going on right now with the Voyager 2's information, that also means that we need to be prepared for what could happen with this wall of fire as time goes on. Number 3. Magnetic fields and magnetic shields. The discovery of the wall of fire wasn't the only thing that people at NASA were interested in when it was discovered. Instead, it was also the fact that there was new information given about the magnetic fields that were there in the outer reaches of interstellar space. You see, our solar system is held within a magnetic field that is comprised mostly of the sun's field, unlike the orbits of the planets and such. Thus, when you get out of the reach of the sun via the heliosphere, it goes to the reason that the magnetic field would go off in a different direction entirely. In fact, that is what everyone at NASA thought before Voyager 1 and 2 proved them very, very wrong. At first, Voyager 1 pointed out that there was some odd directions in the magnetic field of interstellar space. Then, when Voyager 2 arrived on the scene a few years later, its readings proved that the magnetic field of the area was actually parallel with the one of the heliosphere, which is confusing quite a bit of people. Which brings us the need for EM shields. You see, the heliosphere's magnetic field protects the entire solar system, including Earth from cosmic radiation and storms and the like. And so between the wall of fire and the other magnetic fields out there, any ship we have that we send into the stars beyond our solar system is going to need a good electromagnetic shield itself to be its own protection so that radiation and other things don't hurt the crew, the ship, and other vital things. Number 2. The question of space travel. Okay, so now let's talk about one of the biggest problems with this wall of fire. Mainly, how are we going to get past it? No, seriously, if we're going to be talking about exploring the far reaches of space, that means that we will need to get past our own solar system, right? Now, it's true that at present we can't say for certain that this wall of fire encircles the entire solar system, but it's a safe bet, and what's more, the probes were sent out in the direction of where we would likely travel if we wanted to get into deep space. So thus, if we want to go see other planets that are out there, we need to get past the wall of fire, and that presents a couple major problems. First and foremost, until we further examine the plasma, which Voyager 1 and 2 are doing, but can't fully do on their own due to distance and equipment, we won't know the proper way to shield ourselves from its impact in the ways that matter. So at best, we'd be doing guesswork, which is not something that inspires confidence when you're trying to recruit people for a mission. Okay, team, we're going on a mission to head through the plasma field. We're probably going to be okay if the shields hold. So who's in? Yeah, I wouldn't volunteer for that. What's more, the obvious answer of go around the field isn't exactly plausible at present either. First and foremost, that could mean a very long detour, if we're able to go above, below, or around it at all. We honestly don't know just how massive this thing is, because we can only see and understand what the Voyagers detect. So we obviously need more data before that option becomes viable. Now, yeah, we can create plasma very easily on Earth. We do it all the time. That's how plasma torches and other items that have plasma in them exist. But this is on a scale we're not used to, so we need to come up with ways to get through the field if we're going to make it out there. But that's not the only problem that this wall of fire raises. You see, this is an obstacle that we have to avoid, it's true. But what's the next obstacle? And the one after that? And so on and so forth. The Voyagers will never make it out of the true solar system. So who knows what else is out there in deep space that we will have to try and get through. Space is still a mystery to us, and if we're not fully ready for what's out there, it will kill us. Number 1. Space, the final frontier. There have been a lot of interesting things going on in space recently that have gotten the attention of NASA and other space agencies. This is just the latest in that string. But when you put that string together, you get a pattern, and that pattern clearly states, we don't know jack about the universe. Think about it, there is a literal wall of fire just outside the heliosphere, and yet we haven't been able to truly see it until 2019. We found whole other galaxies, planets that may be like Earth, yet we can't see something outside our own system. The universe is so vast that we need to keep exploring it, looking at it, and doing whatever it takes to learn as much as we can. Not just for knowledge's sake, but for the sake of humanity in the future. Our goal is still to try and explore the cosmos, and the more we know, the more we can prepare, the more we'll truly be able to survive and enjoy the final frontier. Thanks for watching, everyone. What did you think of this interesting discovery from the Voyager probes? Does the wall of fire fill you with fear, or suspense, or terror, or wonder? Do you think we'll ever find a way to get through it, and the other obstacles of space? Let me know in the comments below. Be sure to subscribe, and I'll see you next time on the channel.
So that's it. If you think that we can actually leave Earth's magnetosphere, if we can travel outside it, they can use the grandeur. They can tell you over and over again in every way what the Showstopper is, why we don't exceed 230 miles up, why we're sending all the heliophysics satellites up, why Parker Probe's so important, why all of this matters. And you'll just take it and disregard it for your nationalism. Because remember, you believe in the moon landing. You believe in our greatness. You believe. Cognitive dissonance is going to take over, and no matter what is presented, there's no quid pro quo. You'll be full obtuse in every way possible. Everyone's being obtuse right now, so believe what you want. They're saying it over and over again. You cannot leave the magnetosphere without having a magnetosphere on your craft. The end. We're not leaving, and everyone is just now having to realize that we're going to die here. Unless we all stop this bullshit, condescending, fucking smarmy, nationalist pride that is, we did things greater than we actually did. So there you go. Again, social media, NASA, all the universities in the fucking world, they're saying it time and time again. Cosmic radiation, solar energetic particles, these heavy ionization matters, and it's gonna destroy us. Not only is it destroying the planet, we gotta figure it out, but if we want to leave it, we need to create fields of energy we can't even fathom. The end. So, that's the Earth. The end. Grow up, kids. Santa's not real either.